Right now, while you're watching this, Windows 11 is writing data to your SSD. Not because you asked it to, not because any app you opened is doing anything. Just Windows in the background, silently, methodically, writing to your drive while you sit there doing nothing. And the thing is, your SSD doesn't care why data is being written to it. It doesn't know the difference between you saving a file you actually need and Windows quietly updating an internal database you never look at. Every write is a write. Every write consumes a small portion of what is called your drive's TBW rating, its total bytes written limit, the number that determines how long your SSD lasts before its cells begin to degrade and it starts to fail. And Windows 11, out of the box, burns through more of that rating every single day than most people realize. There isn't one service responsible for this. There are several, some well-known, some almost never discussed, and each one contributes to the same slow, invisible drain on your SSD's finite lifespan. Over a year, the cumulative unnecessary writes from these services can add up to multiple terabytes. Over 5 years, depending on your configuration, they can consume 10, 15, even 20 terabytes of your drive's endurance budget, silently, automatically, every single day, regardless of whether you ever touch those features or benefit from them. This is not a hypothetical concern. This is documented, measured, real, and every fix I'm going to walk you through is something you can do right now in Windows 11 without installing any third-party software, without voiding any warranty, and without breaking any core functionality you actually use. But before we get to the fixes, you need to understand the actual science of how SSDs die. Because once you understand that, everything else makes complete sense. SSDs, solid-state drives, store data in cells made of floating gate transistors. These cells work by trapping electrons inside an insulating layer, and the presence or absence of those trapped electrons represents the 1 or 0 of binary data. Reading data from an SSD, simply looking at what's stored there, does not meaningfully wear out those cells. This is important, and we'll come back to it. But writing to an SSD, changing the state of those cells, erasing old data, programming new data, does wear them out. Every write cycle degrades the insulating layer slightly. After enough write cycles, which varies by the type of NAND flash the drive uses, the cells can no longer reliably hold their charge, and the drive begins to fail. Drive manufacturers express this limitation using TBW, total bytes, written. A typical consumer 1 terabyte NVMe SSD from a major manufacturer like Samsung, Western Digital, or Seagate is rated for around 300 to 600 TBW. Some premium drives go higher. Some budget drives with lower quality NAND go lower. What that number means in practice is write 300 to 600 terabytes of data to this drive over its lifetime, and you've consumed its rated endurance. The cells have been through their rated cycle count. After that point, data retention and reliability begin to decline. Now, 600 terabytes sounds like an enormous number, and in the abstract, it is. But here's the thing that makes Windows 11's background write behavior genuinely important to understand. Those TBW ratings assume large sequential writes, the kind that happen when you're copying a big file or installing a large game. What actually happens when Windows writes in the background is something very different. Background writes from OS services tend to be small, random, and fragmented. And small, random writes are significantly harder on SSD cells than large, sequential ones. They produce what storage engineers call write amplification, a condition where the drive's internal controller has to do much more physical writing than the logical amount of data being recorded, because of how flash storage manages its internal blocks. A write amplification factor of 5 means that for every 1 gigabyte Windows tells your drive to write, the drive's controller is actually writing 5 gigabytes internally to manage the operation. Small, random background writes, exactly the kind Windows background services produce, are the worst possible workload for write amplification. They can push the real internal write load on your SSD to multiple times what any monitoring tool shows as the logical write amount. This is why the background services inside Windows 11 matter far more than they appear to on the surface. And this is why, when you add them all up, the cumulative impact on SSD lifespan is something that tech publications like PC World, XDA developers, and make use of have all covered as a legitimate, documented concern. Let's go through every one of these services, what it is, what it does, how much it writes, and exactly what to do about it. The first and most significant culprit is Windows Search Indexing. This is the service that runs behind the scenes to make your searches feel instant. When you click the Start menu and type the name of an app, or when you use File Explorer's search bar and results appear in under a second, that speed comes from Windows Search Indexing, a background process that continuously scans your files, emails, app data, folder names, document contents, and system metadata, and maintains an enormous internal database called the Search Index. Instead of scanning your drive live every time you search, Windows searches the pre-built index and returns results almost instantly. The logic is sound. The execution is the problem. On Windows 11, the search index database has a documented architectural issue that was confirmed by users on Microsoft's own Q&A platform and acknowledged widely in the technical community. The search index in Windows 11 uses a SQLite database format stored in a file called Windows. DB, a significant change from Windows 10, which used a different format with the .edb extension. The way this SQLite database handles updates creates a specific problem. Changes to the index are initially written to a temporary file called Windows, dbwall, a write-ahead log. Periodically, those changes are merged into the main Windows DB database file. The merging process is not lightweight. During the merge, the massive main database file is decompressed, updated, and recompressed. And critically, according to users who have analyzed this directly and posted their findings to Microsoft's developer community, the threshold for triggering this merge, decompress, recompress cycle appears to be set far too low in Windows 11's default configuration. Things that seem routine, receiving new emails in Outlook, opening and closing applications, adding files to synced OneDrive folders, can each trigger the full merge cycle. The result is far more write activity than the architecture should require. How much does this actually write? The numbers vary by usage profile, and there's genuine disagreement between sources about the precise figures. So let me give you the full range from credible sources. One detailed technical analysis found that Windows Search indexing writes 5 to 10 gigabytes of data per day on a typical system with an active Outlook mailbox, OneDrive sync, and a normal document library. Over a year, that's 8 to 3. 6 terabytes. Over 5 years, 10 to 20 terabytes. On a drive rated for 300 to 600 TBW, that's a meaningful fraction of lifetime endurance consumed by a feature you may rarely consciously use. On the other hand, a more conservative analysis argued that a typical user profile without a large email archive or heavy OneDrive activity might see much lower indexing write rates, potentially under 20 megabytes per day in the most minimal configurations. The same analysis pointed out that browser cache, Windows update staging, and page file activity generate more writes daily than indexing does for light users, and that prioritizing indexing as the primary concern may be technically misaligned for some users. Both analyses are using real data. The difference is the usage profile. Heavy Outlook users, people with large OneDrive or SharePoint libraries synced locally, users with massive document folders, these people are at the high end of the write range. People who primarily use their PC for web browsing, gaming, and light document work are at the lower end. Where you fall on that spectrum determines how urgently this fix matters for you. What you should do, in every case, is stop indexing locations that don't benefit from it. Here's exactly how. Press the Windows key and type Indexing Options. You'll see the classic Indexing Options control panel appear in results. Open it. You'll see a list of indexed locations, the folders and drives that Windows Search is actively cataloging. On a default Windows 11 installation, this list often includes the entire user's folder, Start menu shortcuts, Outlook mailbox data, OneDrive files, and sometimes entire program directories. Every location on that list is being continuously monitored and written to the index database whenever files change. Click Modify. This opens a window showing your indexed locations with checkboxes. Remove any location that you don't actively search. Common candidates for removal: the entire C Windows System folder, C/R program files, C program files, x86, large game library directories, especially if you use Steam, Epic, or similar platforms, any video or media library folders, and any development directories where files change constantly. Game files and video files are never usefully returned by Windows Search, yet they consume enormous index capacity and generate constant re-indexing writes as files are created, updated, and deleted by game launchers and media apps. After trimming the indexed locations, go into Advanced Options. There's a button for it in the Indexing Options window. Click File Types. This page shows every file type Windows Search indexes, and critically, it shows whether each type is indexed by properties only or by full content. Full content indexing means Windows is reading inside your files, extracting text from PDFs, reading inside Word documents, parsing email bodies, and writing all of that text into the Search Index database. This is the most write-intensive mode, and it's the one responsible for the large index sizes that people find silently growing on their drives. For every file type that doesn't require full text search, for image files, video files, audio files, executable files, library files, and similar non-text content, find it in the list and make sure it's set to index properties only, not index properties and file contents. This single change, switching from full content indexing to properties only for appropriate file types, is one of the most impactful individual changes you can make for reducing search indexer write activity. It dramatically reduces both the write load during indexing and the size of the index database itself, which in turn reduces the frequency and intensity of the compression-decompression merge cycles that are the biggest source of unnecessary SSD writes from this service. If you want to go further, if you're a user who rarely uses the Start menu search or File Explorer search, you can change the search scope entirely from the Windows Settings app. Go to Settings, then Privacy and Security, then Searching Windows. You'll see an option called Find My Files with two settings, Enhanced and Classic. Enhanced mode indexes the entire drive, your C partition, everything on it, all locations. Classic mode indexes only the most commonly needed locations, your desktop, documents, music, pictures, and videos folders. For most users, Classic mode provides fully functional search for everything they actually search for, while cutting the indexed scope dramatically and reducing write activity accordingly. The second major service is the Windows page file. Technically not a service you stop, but a configuration you control, and one of the most significant sources of ongoing SSD writes on Windows 11. The page file is Windows' virtual memory system. When your RAM runs low, when you have too many apps open, too many browser tabs, or you're running software that demands more memory than your physical RAM can provide, Windows starts moving data from RAM to a file on your SSD called page file. So yes, freeing up RAM for whatever needs it most. The swapping process, by definition, writes to your SSD. Every time data moves from RAM to the page file, your drive absorbs a write. The default Windows 11 configuration manages the page file dynamically. It expands and shrinks automatically based on memory pressure. This dynamic sizing process is itself a source of write amplification, because resizing the page file creates a steady flow of background writes even during periods when you're not actively running out of RAM. On systems with 16 gigabytes of RAM or more, which is increasingly common in modern laptops and desktops, the page file is rarely used for actual memory overflow. But the dynamic management process continues writing regardless. If you have 16 gigabytes of RAM or more and you're not running extremely memory-intensive workloads, setting the page file to a fixed size, rather than letting Windows manage it dynamically, eliminates the write overhead from resizing. Here's how. Press Windows key plus R to open the Run dialog, type SISDM, CPL, and press Enter. In System Properties, go to the Advanced tab. Under the Performance section, click Settings, then go to Advanced in the Performance Options window and click Change under Virtual Memory. Uncheck the box that says Automatically Manage Paging File Size for all drives. Select your C, drive, choose Custom Size, and set both the initial size and maximum size to the same number. Typically 1 to 2 times your physical RAM amount is standard guidance, though on systems with large RAM, the write number is smaller. Setting initial and maximum to the same value prevents dynamic resizing and eliminates the associated write churn. What you should absolutely not do, and this advice appears in various places online and is simply wrong for most users, is disable the page file entirely. Disabling the page file on a system without enough RAM to handle all workloads without virtual memory can cause application crashes, blue screens, and system instability. The page file exists for a reason. The goal is to stop it from dynamically resizing, not to eliminate it. For most users, a fixed page file of 4 to 8 gigabytes on a system with 16 gigabytes of physical RAM is a reasonable configuration that essentially never gets used but provides insurance against edge cases. The third major source of unnecessary SSD writes is hibernation. When your PC hibernates, when you choose Hibernate from the Power menu, or when Windows triggers hibernation automatically after a period of sleep, it writes the entire contents of your RAM to a file called Hyberfill, sys stored on your SSD. Every bit of data that was in your RAM at the moment of hibernation gets written to disk, so that when you wake the machine, it can restore exactly where you were without booting from scratch. This sounds useful. In practice, for most desktop PC users, and for many laptop users who simply close the lid and let the machine sleep rather than hibernate, hibernation is a feature they never deliberately use. The numbers are straightforward. If you have 16 gigabytes of RAM, hibernating once writes 16 gigabytes to your SSD. If you have 32 gigabytes of RAM, it writes 32 gigabytes. And because Hyberfill size must be kept permanently on disk to be available when hibernation is triggered, it occupies that space constantly, even on days you don't hibernate. Worse, Windows 11's fast startup feature, enabled by default and designed to make Windows boot faster, uses a partial hibernation of the system kernel every time you shut down normally. This means every standard shutdown on Windows 11 is actually writing kernel state to Hyberfill. SIS, not just the full hibernation you might trigger manually. Even users who think they never use hibernation are getting partial. Hibernation writes on every single shutdown. Disabling hibernation removes Hyberfill. SIS entirely and stops all hibernation-related writes. Open Command Prompt as administrator, search for a CMD, right-click Run as administrator, and type the command powercfg.h off and press Enter. That's it. Hyberfill. SIS is deleted immediately. The space it occupied, typically several gigabytes, is freed. And every subsequent shutdown is a clean shutdown rather than a kernel hibernation. The trade-off is that you lose the ability to hibernate and you lose fast startup. Boot times from a full cold start may be very slightly longer. On modern NVMe drives, the difference is often measured in seconds, not minutes. For most desktop users and many laptop users who plug in and shut down rather than hibernate through multi-day gaps, this is a trade-off with essentially no real-world cost. For laptop users who do use hibernation across multi-day periods, who close the lid on a long trip and want to restore exactly where they were days later, keep hibernation enabled and accept this particular write load as the cost of a feature you're genuinely using. The fourth source is sysmain, formerly known as superfetch. This is a service that was designed in the era of mechanical hard drives and small RAM capacities. The idea was smart for its time. Windows would study your usage patterns, predict which apps you were likely to open next, and preload them from disk into RAM before you clicked. When RAM was 4 gigabytes and your storage was a slow spinning hard drive, this made a real noticeable difference. Apps seemed to open faster because they were already in memory by the time you asked for them. On a modern system with 16 or 32 gigabytes of RAM and an NVMe SSD that reads at 3,000 to 7,000 megabytes per second, sysmain's core value proposition has almost completely evaporated. Your apps launch instantly from an NVMe drive, regardless of whether they were preloaded, because the drive delivers them faster than the preloading logic was designed to handle. The RAM headroom on modern systems means your actual recently used apps stay in memory naturally, without any predictive assistance. And crucially, the preloading activity that sysmain performs involves reads from your SSD into RAM, and reads do not meaningfully wear out SSDs. On a pure NVMe system with plenty of RAM, sysmain is essentially running background reads that produce no practical benefit, consuming CPU time and memory bandwidth that would otherwise be available to your actual workloads. However, and this is important context for intellectual honesty, disabling sysmain on older laptops with conventional SATA SSDs and 8 gigabytes or less of RAM can produce genuine, immediate improvements in responsiveness. On those systems, sysmain's preloading activity can cause noticeable disk utilization spikes that slow everything else down. XDA developers documented exactly this scenario in a 2026 piece. Sysmain was designed for and benefits mechanical hard drives and older, slower systems, but on modern NVMe machines, it's at best neutral. To disable sysmain, press Windows key plus R, type services. MSC, press Enter. In the services window, scroll down to sysmain, double-click it, change the startup type from automatic to disabled. Click Stop to stop it immediately, then click OK. Monitor your system for a few days. If you notice any degradation in how quickly recently used apps reload, you can re-enable it the same way. On most modern systems with fast NVMe storage and adequate RAM, you will notice no difference. The fifth source is telemetry and diagnostic logging. Windows 11, even on Home and Pro editions, runs enterprise-level telemetry collection in the background. This involves continuously logging diagnostic events, application usage patterns, error reports, performance metrics, hardware telemetry, into local log files that are periodically transmitted to Microsoft servers. The logging process itself generates thousands of small writes per hour. Individual writes are tiny. We're talking about log entries, not large files. But the cumulative effect of thousands of small writes per hour, every day, produces a meaningful add to your SSD's total write load over time. Multiple sources measuring Windows 11's background or write activity have specifically called out telemetry logging as a contributor to the overall write pressure on the OS drive. To reduce it, go to Settings, then Privacy and Security, then Diagnostics and Feedback. You'll see an option labeled Diagnostic Data with 2 settings, Required Only and Optional. Set it to Required Only. This doesn't eliminate telemetry. Windows still sends some basic diagnostic information regardless of this setting, but it stops the continuous optional diagnostic collection that generates the most background logging activity. This change is easy to make, takes 20 seconds, and reduces the source of background writes without affecting anything you'd notice in daily use. Now let's talk about what you absolutely should not disable, because some content on this topic goes too far, and disabling the wrong things can make your SSD fail faster, not slower. Do not disable trim. Trim is the command protocol that allows Windows to tell your SSD which data blocks are no longer in use. They've been deleted, moved, freed up, so the drive's internal controller can properly manage those blocks in advance. Without trim, the SSD's garbage collection process becomes much less efficient. It has to do more internal work during write operations because it can't clean up freed blocks in advance. This dramatically increases write amplification, the exact problem we're trying to reduce. Trim is SSD essential. To confirm it's enabled, open command prompt as administrator and type fsutil behavior query disable delete notify. If the result says disable delete notify from 0, trim is enabled. That 0 means trim is not disabled. You want that 0. Do not change it. Do not disable scheduled optimization. You may see advice online telling you to disable the scheduled optimization task, which is the replacement for defragmentation on SSDs. On a mechanical hard drive, defragmentation physically reorganizes data to reduce seek times, and doing it repeatedly is genuinely harmful to an SSD because it involves enormous amounts of unnecessary write activity. But Windows 11 is smart enough to know the difference between a mechanical hard drive and an SSD. When scheduled optimization runs on an SSD, it doesn't defragment. It runs trim and performs retrim operations that help the drive maintain its performance and efficiency. Disabling scheduled optimization on an SSD doesn't save your drive. It actually prevents the maintenance that keeps trim working properly over time. Do not disable the page file entirely unless you have 32 gigabytes or more of RAM and a specific, well-understood workload reason to do so. Removing the page file on a system that occasionally needs it causes crashes, not just slowdowns. The goal is to fix its sizing, not remove it. Let's also address something that's worth saying clearly about the overall picture of SSD longevity in 2026, because some content on this topic either overstates or understates the concern, and you deserve the accurate version. Modern NVMe SSDs are genuinely durable. A quality 1 terabyte NVMe drive rated for 600 TBW will, under normal home and gaming workloads, last many years without any of the tweaks described here. The story of Windows 11 is immediately destroying your SSD is an overstatement. SSDs don't fail cleanly the moment they hit their TBW rating. They degrade gradually, showing performance reduction and latency increases before actual failure. Now, most SSDs fail from controller issues, overheating, or manufacturing defects long before write endurance becomes the limiting factor. What the tweaks in this video address is the meaningful but not catastrophic contribution of unnecessary background writes to the slower, incremental wearing of your drive's rated endurance budget on a standard 1 terabyte drive, rated for 300 to 600 TBW, eliminating 10 to 20 terabytes of unnecessary writes over 5 years, which the search indexer alone can produce in aggressive configurations, extends the practical safe operating window of that drive by years. Not decades, years. The impact is real, measurable, and worthwhile. It is not an emergency. It is maintenance. The kind of maintenance that, like changing your car's oil, doesn't matter at all until the day it really matters. There's one more thing worth checking regularly that most people never do: monitoring your SSD's actual health directly. Every SSD maintains internal telemetry data, smart data, it's called, that tracks total bytes written, remaining life percentage, reallocated sectors, and other health indicators. You can see this data using free tools. Crystal Disk Info is the most widely used and respected free tool for reading smart data on Windows. Install it. It's available from the developer's official website. Open it, and you'll immediately see the current health status of every drive in your system, your total bytes written lifetime, and your drive's remaining percentage of rated endurance. Checking this once a month takes 30 seconds and gives you genuine, real data about how your specific drive is wearing under your specific workload. It turns the abstract concern about SSD lifespan into a concrete, trackable number. If your daily write rate looks reasonable and your remaining endurance is healthy, you can calibrate exactly how urgently any of these tweaks matter for your situation. Let's bring it all together with a clear priority order, because not every fix carries equal weight. And knowing which ones matter most for your specific situation helps you act efficiently. If you have a large Outlook mailbox synced locally, a large OneDrive or SharePoint library, or a document-heavy workflow, search indexer configuration is your highest priority fix. Trim the indexed locations to only what you actually search. Switch to properties-only indexing for non-text file types. Switch to classic mode in searching Windows settings. This is where the biggest measurable reduction in SSD write activity comes from for heavy users. If you have 16 gigabytes or more of RAM and you're not running memory-intensive professional workloads, fixing the page file to a fixed size is your second priority. It's a simple change that eliminates continuous dynamic resizing writes. If you're a desktop user or a laptop user who doesn't deliberately use Hibernate, disable hibernation. Free up several gigabytes of disk space and eliminate both full hibernation writes and the partial fast startup kernel write on every shutdown. Set diagnostic data to required only. 20 seconds in, settings, done. Disable sysmain. If you're on a system where you notice responsiveness issues or high disk utilization during idle periods, especially on older machines with SATA SSDs or 8 gigabytes of RAM. On modern NVMe systems with plenty of RAM, this one is optional. Confirm trim is enabled, never disable it. Do not disable scheduled optimization. It's doing maintenance your drive needs. Install Crystal Disk Info. Check your drive's actual health and write statistics. Make decisions based on real data about your actual drive, not generic alarm. Your SSD has a finite life. Windows 11, out of the box, burns through more of it than it needs to. The fixes are real, they're documented, they're safe when done correctly, and they're in your hands right now. Every one of them can be implemented today without any additional software beyond the free tools already mentioned. And every one of them is reversible if you ever change your mind. Stop letting Windows decide how your SSD ages. Take 2 hours, make these changes, and let your drive spend its endurance budget on the things you actually do. Not on background services running automatically in the dark,